Hello, gentles and ladymen. I'm Spiro, and I'm not a wizard. So in my first video I made on this channel, I was going through a adventure game writing book which had how to write text adventures in BASIC, and I went through that book. It was a bit interesting. I learned a few things on how to structure the game code itself, like how to lay out and how to how to reference things like the locations, the objects, and everything that the player interacts with. And my heart though has been set on properly learning assembly language and writing a game in assembly language. Unlike the other game I released just last week, which was Wordle, which was written in BASIC and took me less than a day to write. This is probably going to be a longer term project. I've started working on some of the fundamentals. I'm not entirely. I've kind of been working on the code. I'm probably doing this the wrong way around, rather than designing the game content at the moment, because I kind of want to have that framework, because I know that framework is probably going to take me a lot longer, and it's going to be a lot harder and have a steeper learning curve than writing the actual content of the game. So keep that in mind, that when I run the game, it's effectively placeholder text so that I could learn things. Maybe it will be the beginning of the game, I'm not sure. So I am using TurboAS 5.2, which is this is the version that was last modified by Bacchus of Fairlight. This is something I used years ago when I was playing around, and I think that might have either been before I knew about Turbo Macro Pro, or maybe it was before Turbo Macro Pro was released in its current incarnation. Anyway, TurboAS has the features I want, and it's a bit smaller, and I thought that was important for me, because I was kind of going back and forth. I've since, so I'm writing this and I'm showing this to you on a Vice emulator. I started writing this, the majority of this code was written here on my Linux machine in Vice. Today I have finally successfully got my real 64 working properly to the point where I'm able to continue development on that, and I'm saving the code on actual floppy disks. I had a problem initially with my floppy drive. I opened it up trying to clean the heads because it would read a few disks and then just stop reading stuff. But my friend of mine gave me a whole lot of his disks, and they were deteriorating, is probably the truest way of putting it. They had what looked like to be a little bit of mold on them, but I think the majority were the oxide, or the coating, whatever you call it, that coating layer has been deteriorating, and I thought that was what was contributing to the drive stopping to read. I cleaned it again, but I got to the point where it just wouldn't load any disks at all, even disks that were being read before. And I got some advice from someone on Reddit saying to just chuck in a known good disk, of which I kind of didn't really have any, so I grabbed a couple of disks that just didn't look as bad, and their suggestion was just format a disk 6-7 times if you have to. That kind of kicks the drive into life, or realigns the heads, or does whatever it does. And I thought that would have been just like bashing your head against a brick wall. It's like, I'll quit it. Not achieving anything. But it turned out after 5 formats of a disk, it formatted. I managed to get the directory back, and I was like, okay, cool. So I went through, I formatted a few other disks, and they all seemed to work fine. And yeah, I bought an SD2 IEC, which is a SD card adapter for the C64, and I started copying over some of my files to that, thinking that if I couldn't get the disk drives working, I could still at least use the 64 with that. But again, a bit more digging, a bit more, once I got the disks reading, I found that DRA Copy allowed copying files from the SD2 IEC, the SD card reader, to real floppy drives and vice versa. So I used that and copied a few files over as a test, one of them being Turbo Assembler and one of them being my source file. But now I save my source files as sequential files, so not as PRG files. So instead of using the save feature, I use the write feature. I'm not entirely sure what the difference is, but I did find that the sequential file format was more portable between different assemblers. I'm not sure if that's actually the case, or if I had a corrupted file. So I've just kind of stuck to writing or saving my source code as sequential files. And I found that DRA Copy, there were some interesting things I learned. So Vice has got the C1541 program, which allows you to read D64 files. It allows you to save and export files from a disk file, and that when I copied over my source code, I didn't realize it had saved it as a PRG file. So I went back, found out how to save it as a sequential file in Vice, and transferred that through to the 64. And when DRA Copy copied, I did a single file copy, DRA Copy copied it and saved it as a PRG file, which Turbo Assembler then couldn't read. It knew it wasn't a sequential file, so it couldn't load it with that, and so I tried loading it using the PRG load command, and that just came out as junk. So I ended up doing a disk copy from my virtual D64 file to a physical floppy disk, and that's been fine. And so I can now, touch wood, code on the C64, the real hardware, using floppy disks, of which I'm sure I'll save my file to multiple disks each day, just in case, and then back it back up to the SD card once I've made some significant changes. So it's been a very successful day for me, and I am quite chuffed about it, and now I just want another nap. I've already had two today because it's southern hemisphere and it's very hot down here in summer this year, I've had a lot of naps and ice cream for dinner. It's been crazy. Onto the code. So I'll give you a basic rundown of what I've done, and I please point out things that I'm doing wrong if you have better ways of doing things. A lot of this has been over the last couple of days, just kind of me banging against the code until I finally got something that worked, and trying to find other source code online to try and figure out how to do things. If I go to the very bottom, we'll see my title screen text is more than 256 characters. So the first thing I had to try and do was figure out how to display a block of text that was more than 258 characters, more than 256 characters, without it stopping part way through. So I did that. I had written a get input routine a while back, so I've reused that code, and so I've kind of almost got some of the fundamentals going. I can display big blocks of text. I can get user input, and I'm just kind of going through things in a methodical way, just going, okay, well, what do I need to do next? Ignoring the content and what is there, just trying to get the content displayed in a proper way. Anyway, so I start off here, set up a few variables. I tend to use, there's a few 0-page variables that I'll use. I tend to put, as a course of habit, my counters into FC. So there's a couple of there's 4 free bytes around that area. Oh, what is it? FB, C, D, and E, I think it is 4 free bytes in 0-page. So I use FC as my counter because in my head it stands for the frickin' counter. The player location I'm storing in FB, and that is going to be the room that the player is in. So when I draw my map, and I have here a bunch of boxes that I number 1, 2, 3, 4, 5, 6, 7, and I figure out from there where the user can go to, east, west, north, south. That room, that location, gets stored here. I've got an input buffer which is 16 bytes, which is going to be the input that the user types in their commands. Now I put that at the beginning of the program because in my head I think if it's going to be referenced regularly, I probably want it closer to the code rather than kind of buried deep in some other higher location in the data, and the pointers have to be much larger, and maybe it'll slow down, I'm not sure. So I've got a few screen codes, PETSCI codes, whatever they are called, for things like jumping to the home location is $13, turning reverse on and off, and setting some colors. So the initialization, I turn the background black. I set the player in room 1, and I clear the screen. I switch to character set 2 so that it has got the lowercase character set, and I disable the toggle. So here is where my interesting learning, my first big discovery came in, which was the ability to print a string of text more than 256 characters, having to load the low byte and the high byte into these 0-page registers. Hex 19 through to hex 21 are 0-page addresses that are reserved for string manipulation. So I chose the top two to be my to store the address of the strings. So every time I'm going to print a string, then I'm going to load it into these two memory locations and then jump to the print routine. So at the moment I'll print my main title screen, I'll do a screen pause, and then my main loop, I've currently got it so that it shows the current location. It'll print the prompt, which is basically just a that and a space, like a command prompt to say, enter your. It will get the user input, and then it will display that buffer back to me so that I know that it's working. Then it'll print a pause before re-enabling the character set toggle and setting the color back to yellow, because that's what TurboAS uses, and then it'll quit out. So some of these, the print prompt literally just prints a a right angle bracket and a space, and I just use the ROM kernel print character out or kraut routines, as I call them. So that's a subroutine there. The pause prints my pause message. Because that's a short string, I don't do the full loading the high and the low bytes. Pause, and then it just waits for any key to be pressed, and then it releases back. So I've got a print routine, so it expects the low byte in 20 and high byte in 21, and then your JSR print. So this is kind of really all it is. I mean, that was probably a day's worth of work trying to figure that out just on my own. Yeah, so I load the offset here, which is going to be my offset counting through the string. I load the low byte, the contents of the low byte, into the A register. If it's a 0, then that is I put a null character at the end of all my strings, so it knows that it's finished with the string. Cycles through that. If the string is greater than 256 bytes, then increment the high byte of the address as well, and then jump back and do the same thing, load the content, which is the character in the string. I've got a show location code. I was thinking about using this pushing stuff to stack. I haven't figured that out yet, so left that commented out for the moment. So this basically goes to, it clears the screen, then it prints the home character, so it'll jump to the top. I put that there just in case I reference this route or this label out of context of this. For a text-based game, those extra cycles aren't killing it. Turn reverse mode on, turn it to white, add a space at the beginning, and then print the location name. So I've got a string. I've got a string at location name. I basically so this basically loads the base address and calculates the offset based on your room. So what I've done is I've set a bunch of strings that are all exactly the same number of characters, because that was the easiest way for me to do it at that time. and they're all 16 bytes, so it's 15 bytes for the name, and the 16th byte, excuse me, is the null terminator, the 0 byte. So what I do is I load the player location. I store that into a 0-page address, which is $19 or hex 19. So that is one of those string manipulation memory locations, and then I shift it, multiply it by 16. So that is because that is the number of bytes in each string. Update that base address, add that to the base address. This I think is going to break once I've got a lot of once I've got a lot of locations, and that calculation starts resulting in numbers bigger than 256. So this is going to break, I know that, but at the moment it's kind of working. And then I subtract 16 because the data starts at the 0 offset, and we start in room 1. So 1 times 16 is going to give us a base offset of 16, but we want to start at 0, so I remove 16 from it, and then I print that out. I pad the title with spaces, so the whole top line becomes a bar of reversed white, and then I turn off the reverse, switch to light grey, print a blank line, and then I move on. So these are still to do. Print the location description. At the moment that is not working. Print the objects, I haven't done that code yet. And then I do the exits. This part is working. So again, it'll print a little exit message saying your available exits are, and then it'll figure out the offsets. I might jump to that now. I'll show you how I do that. So my exits table is here. So it's basically each one is 4 bytes. So that was again why I was doing a similar offset to my location names. The location names is here. So these are all 16 bytes. So you set the first offset here. Second room will be here, third room will be here, fourth room will be here. So similarly with my exits, I've got 4 bytes, and a 0 means that exit is not available. A number means that exit takes you to that location. So I've got here north, south, east and west. So this is north, this is south, this is east, and this is west. So when you're in the first room, you can only exit south and east, and the code goes through that, and so does these 2 shift left, so multiply by 2, then multiply by another 2, so we're multiplying by 4, which is that 4 bytes. We subtract 4 because again we're base 0, not base 1 to start. And then it goes through and it reads all of this. So I've had to do this manually. I don't know a better way of doing this, but what I do is I check the first byte, which is north. So I check for the north exit. I store that number in 0-page location 1C. So this, if you remember, is another one of those string manipulation locations between hex 19 and hex 21. So it'll put the first one here. So I use 1C, 1D, 1E and 1F to store my north, south, east, west. If the number that it pulls is not 0, then it will print the word matching the exit. So print north will print the word north, print south will print the word south, and so on. So what I do is I print north, and then it actually it loads this value into the X register so it can do a check, because loading something in the X register will affect the 0 flag. Then I if it's equal, so if the north, see, because 1C is north, right, but when we're printing south, if north had a value in it, rather if north didn't have a value in it, right, and not a non-zero, so if there was a north exit available in this location, sorry, it will print a comma, so it'll print a comma and a space. If it was equal to 0, then it will just print south, because south is probably the first location it's encountering. It does this again, it checks if it printed east. So if it printed south, it'll print a comma, otherwise, and then it'll print east, and same west checks for existence of an eastern exit, and if there is, it will print a comma, and then it'll print west. So the print comma routine prints the 2C, which is the screen code for a comma and a space. Okay, so that, let me give you a little quick, let me just assemble that and start it. So to show you how it's looking now, I don't know how long this video is, 27 minutes. You're used to long videos from me. I'll start that. So this is the first screen, which is that big long string of text. That's probably not going to be the final name. So if we remember back to our main loop, I printed the title screen and then I printed a pause. So I've got a pause here, I press space, and then it will take us to the show location. So it's now telling us that the location name is a dark room, and the available exits are south, comma, east. I can enter in, and as you can see, it only takes 16 characters. That is my limit. So you can type in anything you want, take, shoes, and in this test instance it'll just print back what I typed in, and that was useful to verify. Like when I first wrote it, I was when I pressed delete, it would add a 0, but I added the 0 byte after I had already changed the offset, so it was actually putting the 0 byte 1 ahead too far. So that shows me that it has ignored everything that I deleted after that, which is great. And that's it, that's my code. Another reason I use TurboAS 5.2 is because I can hit restore and it takes me straight back to the code. So we've got that. So that's that display buffer, displays back what I typed. My get input routine sets, as you saw, sets reverse mode, sets it to yellow, sets the buffer length, which I defined at the top as 16 characters, or 16. So my buffer length I've defined as 16 because that's how many bytes there are. And we go back down here eventually. There we go. So what I'm actually doing is storing what I type in reverse order. Now I don't know if that's a good idea, but it was simpler for me to write the code to do that, and which is another reason why I wrote that display buffer routine, so that I could verify that I could read it back the right way around. So what this does is when you run the get input routine, sets that up, clears the buffer so that if there was anything you typed before, it'll zero it all out, and then it'll get into the get input read function, checks to see if you hit run stop, and then it'll exit, which is just takes you to a break command. Runs the kernel get input or get in routine, so it'll only accept and it'll only only go to the finish label once you press return, and that is so that once you fill the buffer, it doesn't automatically say, okay, you filled it up, that's it, that was your string. It gives you the opportunity to go back and delete characters if you're not happy with it before you press return. It will check if the return is pressed, and then it'll check if you hit the delete key, and it'll delete a character. It'll check if you press space, then it will go to the print character routine, and then it makes sure that the other characters you type are between A and Z. So I'm not accepting any odd characters, I'm not accepting any Petsky graphic characters, I'm not accepting numbers, nothing. It's just text, space, A to Z space is all it will accept. And once it's happy with that, it's probably a letter, so we'll go to the print routine. This is the delete character routine, so it puts a 0 into the counter and into the buffer. It stores that into the input buffer. Sorry, it stores the 0 into the input buffer. The print character routine, the first thing it does is it checks if the buffer is full. So if you've already entered in 16 bytes, it won't let you enter in anymore. It will still go to this routine just in case you hit delete or return. But this is basically just a so it'll load the counter if the counter is equal to 0, and that was another reason why I did entered the characters in reverse, so I can just do a simple check for 0. If it's 0, go back to the read routine, so that you will allow delete and return to be pressed. It'll output that character so once it's happy with that, so the character, there is room in the buffer and it's a valid character, it'll output it to the screen, and then it will store it in the input buffer. And as you can see, we're decrementing the counter, so we're storing that in reverse order. And then it'll jump back to read the next character. The finish routine turns off the reverse, goes to light grey, and then returns. So that's the bulk of what I've got code-wise. The rest of it is just data, so I've got the pause message, available exits message, printing the north, south, east, west. I've got a few response messages. I'm not sure how this is going to work. The verbs, these are the verbs that I think I want to accept. So I've listed them here. I don't know how I'm going to use them. The item table or the objects, I don't know how I'm going to implement that yet, but based on that Adventure Game Writer's book, that guy had set up flags for the item, so he'd had the state. So then I can say, for example, if something gets destroyed or if it's hidden or something, I can mark it as a different state. So if the state is 0, it doesn't have any other weird state, so it's available and it'll be viewable in the room. This is my theory. There's a flag to see if the item can be taken, to see if the item is wearable, to see if the item is edible, or if it's drinkable, or if it's openable. So if it's edible, drinkable, then this will mean that it's then unavailable or has been consumed. Maybe I'll need another flag for that, in case you can still take it. Say a bottle, drink it, but you can still take the bottle. So I might have to add to that. My location table, as you saw, each room has 4 bytes to manage its exits. So I guess this kind of is like dimensioning an array. The location names again is basically another array. I found this easier, having them a set number of bytes, treating it like an array so that I could have those offsets set at programmable distances. The thing I'm not sure about how I'm going to do is the actual descriptions for the rooms. So if I have a location description, they're going to be variable length. So I thought about trying to have some kind of a jump table, and I messed around with setting a location 1 description equals lock 1 desk, which would take you down here, and I was thinking that could store the address of this. So that's what I'm trying to figure out next, is how do I reference easily programmatically without having to cycle through all the data, the offsets to the descriptions of each location. If you have any ideas, I welcome them. Please leave them in the comments below. I haven't quite figured out how to do this yet, so that's my next goal, my next thing I need to try and achieve. And then the rest of it, the last of it, is just that title screen. And that's kind of what I've got so far. So it's possible that once I figure this out, I might be able to change this so that I can have longer and shorter names. But at this point it was just easy for me to just get to a point where I could set up and show, okay, look, I've got my room name printing up and I've got something showing up, and that is relevant to the room I'm in. So if I go to say for example, if I set the player location to 3, we can go down and see that player location 3 is going to show us we've got the exits will be east and west, and the description, the name, will be a corridor. So if I run that, and it says I'm in a corridor and the exits are at the east and west, which is quite good. I will just show you now, if I can remember, if we use the monitor, if I go to 19, this shows me, oh, where is my mouse gone? Oh no, too many things have changed. Where did I store my room numbers? So if I go 1C, so if you remember where I stored my exits for the room I'm in, we're in 1C, 1D, 1E, sorry, 1C, D, E and F. So you can see there that matches north, south, east and west. So rooms 1 and 4, east and west. What else can I show you? If I go to 1000, I should be able to go. Oh, I didn't type anything in my testing. So now if I go into the monitor and I show you the beginning of the code, so my byte, that's my 16 bytes that stores that input buffer is up near the top. So you can see I've got here, if you can't see the mouse, oh my god, so I've got testing. You can see at location, why does the mouse disappear now? I'm always having technical problems, aren't I? But you can see testing is in there, starting at 1013 in reverse, and there are a bunch of 0 bytes there to pad out the rest of that 16 bytes. So that's what I got so far. I think I'll leave this video here because it's probably pushing an hour. It's 42 minutes. Still working on it and really happy now that I can keep doing some of this now on the real hardware. I'll see how that goes. In a way, I kind of like doing it on the computer, on Linux and in Vice, because it means that I can have PDFs loaded on, in the side window, which I tend to do occasionally. Reference books, or I can load up my web browser in another window and have the memory maps loaded and things like that. Maybe once I amass a collection of reference books, I'll be able to do that easier, or maybe I'll just set up one of my laptops next to my C64. But yeah, that's what I got so far. Let me know what you think. If, as I say, if you've got ideas, if you've got help, any pointers, or any references you can point me to that might show me how to start working through some of those variable sized strings and still be able to reference them, like either with a jump table or something, I would really welcome that. Otherwise, thanks for watching, and I'll see you when I have some more updates. Talk to you later.